Okay, today's lesson will cover both sections 1.8 and 1.9 on recursive formulas for sequences. Reason is two sections because the author tries to teach you to use a little, if you read, the blue button answer key, but then he takes it away in section 1.9. So we're just going to actually work through it without the little blue button combination because it's something that goes away. So I've sort of put the two sections together. We'll do a few problems from each. We won't make it 2 days worth of work. So looking at section 8's goals, write a recursive definition for a sequence, and then try to solve real-world problems as well. Then also 1.9, we're going to be able to evaluate sequences, write the recursive definition for the sequence, and use real-world problems. So you can see both of them are related to each other, but we will go through some of the definitions, vocabulary, and actually how you work the equation. But this is your second type of way, or second way, your sequences can be written. Not all sequences are explicit, which we already learned, and now we're going to talk about them being recursive. So let's move ahead. What are they? And again, what is the difference between the two? Now, explicit, you have learned the definition or the shortcut of it is you should be able to go directly to what you need. Whereas recursive, it's right in the word, it's a recurring process. You can say a recurring sequence. It doesn't mean that you have repetition going on in the problems. It doesn't mean, for example, if I started 1, 3, 3 for a sequence, that doesn't not necessarily mean recursive. But it does mean you have a repetitive pattern, and you're going to have to use something that you previously evaluated to get the next thing. A repetitive process is being used, recur over and over again in your work. Now, as we talk about sequences again, let's review a couple things. We always called the first term in our sequence, whatever it was, t sub 1, then we did t sub 2, then we had t sub 3, terms in our sequence, and so on. Now, what if I did something like the second line? We could still do t sub 1, t sub 2, t sub 3 in naming our terms in our sequence. However, this next one, because we did the dot, 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 you do not know how many terms we've bypassed. You don't know how many were in that dot, dot, dot sequence. So the question is, what do you call this next position? We've been talking about it, we've been using it, and then there's one after it, and one after it. So we have been using the idea of t sub n to refer to any term in our sequence. So let's assume now we don't know what this is, so we'll call it t sub n. But then the next question begs, what would that one be? Well, any term in a sequence is consecutively 1 apart. So we know that these are moving by 1, so whatever number this is, this next one has to be 1 more than it, so it would be the subscript t sub n plus 1. And then continuing that pattern, t sub n plus 2. So you can name them all, you just can't tell me exactly, oh, this one is the 10th term, and this one's the 11th. You can't tell me that because you have no idea how many terms were missed, skipped in writing your sequence. All right, so a recursive versus explicit. Explicit, you should be able to go directly to what you need. Go to the 55th term if that's the term you're looking for. Go to the 15th term. But in recursive sequence, you must follow the pattern and do the repetition that recurs to give us the first, then the second, then the third. Because in order to get the third, you need to use the second and the first in order to, or at least the one previous. So keep that in mind. Recursive, you have to have a previous term to get there. Now, let's talk about that in relationship to this last line. If we would say we were working on T sub 1, T sub 2, T sub 3, we'd be good. Then we skip a bunch of them. We don't know how many. So this is our current term. We're sitting right here. What would this be called? Well, the next term. And that's why we said T sub n plus 1. So now if I went backwards and said, I want the term that came right before this T sub n term. Some of you would say, oh, it was the one before it. Some of you would say in words, it was the previous term. Well, I need to know what the subscript would look like. These are the subscripts on these terms. What's the subscript on that one? Remember, they're only one apart in sequence. So the subscript for our previous term, and that's key here, would be T sub n minus 1. And that's going to be a big piece of what we do in this section. That subscript, T sub n minus 1, will always stand for the previous term if we're considering T sub n to be the current term. T sub n minus 1, previous term, big piece of the recursive situation. So now, if we go to a sequence that says, oh, here's an equation, and it's a little different looking than what you saw with the explicit ones. We want to find the first 4 terms of this sequence defined by, and notice there's a 2-part process, and it is connected with a set bracket. So that connection is key. So we want the first 4 terms, so most people will, start by putting their 4 little blanks down. Those are the first terms. Or they'll do T sub 1 equals, T sub 2 equals, T sub 3 equals, T sub 4. We were already given T sub 1. So we're going to take that and put it in the first slide immediately. Then, here's where we have to learn a bit. The second line is key for the rest of the equation. You say, how do you know? Because I'm looking at this T sub n, and I'm connecting it with this statement at the opposite end of the equation. It says T sub n is going to be equal to whatever this is, which is fine, but it says for all integers n greater than or equal to 2. So if this was T sub 1, I know this second line will calculate, because of this statement, it will calculate the second term, the third term, the fourth term, the fifth term, the sixth term, the 88th term, the 112th term, any other terms that are in my sequence. That line will help me calculate. Okay, so I can do that. So if that second line is going to help me calculate all those others, then I should be able to get to the first 4, which is what we're asked for. So I know I have a first term of 3. Now, focus in on just that equation that falls after the equal sign. If we said in words what that equation looks like right now, most of you would say 2 times T sub n minus 1 plus 1. But I believe in our last slide, we just said something about that T sub n minus 1. We called it the previous term. You say, wait a minute, come back. If T sub n is the current term we're on, T sub n minus 1 has to be the one that came before it. So if we're working on our second term, which we are, because we already had the first term, then T sub n minus 1 had to have been that first term. So if we put the numbers in to figure that t sub n minus 1, you're not saying don't figure it, just it's the previous term. So t sub 2 would be 2 times my previous term. Well, the previous term of the second term is the first, so that's a 3 plus 1. 2 times 3 is 6. 6 plus 1 is 7. My second term is 7. Now let's do that again to help calculate our third term. So now think of the n as a 3. So up here, scratch work, t sub 3 is going to equal 2 times the previous term plus 1. Well, I'm on the third term, 2 times the previous term. That would turn us in 2 times 7 plus 1. 14 plus 1 is 15. That t sub 3 is 15. One more time. To get the fourth term, we would need 2 times the previous term plus 1. 2 times the previous of the fourth is the third, so 2 times 15 plus 1 is 31. We have just come up with our first 4 terms of the sequence. Using the key rule in the blue box, but replacing that t sub n minus 1, which stands for the previous term, with a different number each time. Describe the equation in words. Now, this is the hard part. We're going to practice this a little more in class tomorrow. But you have to, if I take all of this stuff away, you have to be able to take those two equations and say them with meaning so your brain knows exactly what to do. Now, I'm going to read it. What we say is the lazy man's way of reading it, and which a lot of us do. You'll catch me doing it. The equation, t sub 1 equals 3. T sub n equals 2 times t sub n minus 1 plus 1 for all integers n greater than or equal to 2. Now, if you read that and you read it just like that, you don't put a lot of meaning behind it. So we want to dissect what this equation really says. And in doing so, we're going to come up with those key words we talked about before. What's a subscript? What's a term? Where am I at? And a lot about the notation. So here's what we want to do. We want to turn it into English. So that's not going to be that difficult. We'll start with the first line. And since it is the first line, we're going to say exactly what this means. Not what it says, what it means. So we're going to say the first term in our sequence is 3. Okay? Then we move down to the next line. We can't say our second term because that doesn't stand for second. But we know if we put it together with those words, it stood for the second, third, fourth, fifth, sixth, seventh, eighth, all the way till whatever we want. So we need to find a way to say that in English. And we don't want to say the second term. It might have to be a phrase. And probably the phrase that does it best is all other terms in the sequence. So if we will say, using those two purple things together, all other terms in the sequence, then we can go back and use our subscript of t sub n minus 1, standing for the previous term. And then I think we'll say the rest of it, 2 times previous term, that would work, and then plus 1. So now I think by taking a few of those subscript pieces, putting them together, actually putting words to them for meaning, it will now make sense. So with them up there, then I'll take away and see how it goes and see if you can get it. So reading it one more time, reading the equation, describing the equation in words would be, my first term in my sequence is 3. All other terms in the sequence will be equal to 2 times the previous term plus 1. So you have just told your audience what they have to do to get each of the terms in the sequence. All right, now if I would take it away, all the cheat sheets, and ask you to now describe it, try it once on your own, in your head, and then I will describe the words to you. So try it. And now how about, let's see how you did. Did you say the first term in the sequence is 3? All other terms in the sequence are equal to 2 times the previous term plus 1. If so, you did a good job. If not, we're going to keep working on it anyway. We will get better. So here is a recursive sequence, and we want to write it in the equation form. All right. In doing so, let's take our first piece. Our first piece is question, what is the first term? It's easy. Now you can go with what we've been doing, t for term, or you can make your own variables, but we'll go with t for term just for purposes here. So I'm going to start with t sub 1. My first term is 15. Then, before you can figure the next line, which must start t sub n, because it contains second, third, fourth, sixth, 100th, whatever term you want, you must look at your sequence and determine what's happening. Is there a pattern? So let's see, it's definitely going down. It's going down here by 4, going down by 4, 4, okay, you might want to say, add or subtract, your choice. I think we found the pattern. There is a distinctive decrease of 4 going on in our pattern. All right, and it's always a decrease of 4 from the previous term. So all other terms in our sequence will be equal to the previous term, t sub n minus 1, we learned. And then what are we going to do? We're going to subtract 4. And then do not forget that statement that tells us this is for all other terms in the sequence. We say for integers, and we can abbreviate for int, integers, n greater than or equal to 2. Now, a little short discussion here, because you will see it in the book as well. Could I say n is greater than 1? Is that the same set of numbers when we're talking about n being a counter or an index? Just because I do this doesn't include any other numbers. I believe both those sets are equivalent when we're talking about index numbers, which are our whole numbers. So you might see a different statement down here. Does that make it wrong? No. As long as it is the same equivalent set of numbers, you should be good. So there's our recursive formula for that sequence. So given the sequence, you can write the formula. Given the formula, you should be able to write the sequence. So let's try one of those. Here is the formula. There is no sequence, so you have to find it. And specifically, look at the question that's asked. Find v sub 1 minus v sub 5. So before you can even do the problem, you need to at least make a sequence out through the 5th term. Because you can see in your work, you need those terms. So let's make our little sequence through 5 terms. And we got some scratch work if we need it. Now, reading it for meaning, I'm seeing the first term in our sequence is 15. So let's write it. Then all other terms in our sequence will be equal to our previous term minus 4 times n, which is our counter, plus 2. So let's go. We want our second term. It'll be our previous term, which was 15, minus 4 times our counter. Our counter is currently at 2, and then we're going to add 2. So 15 take away 8 is 7. 7 plus 2 is 9. V sub 2 is 9. Let's go to V sub 3. V sub 3, previous term, so that's 9, minus 4 times our counter. Our counter is now a 3, or in the third term, and then plus 2. So 9 take away 12 is negative 3. Negative 3 plus 2 is negative 1. Our third term is negative 1. And we'll continue in that fashion. So why don't you try this one, finish it up, and see what you come up with for V sub 1 minus V sub 5, so that we can have a discussion on that in class and see if we have any issues. And when we do come back to class, we will have, as I said, 2 days worth of work in this section on practicing and getting really good with how you rewrite recursive sequences to their equations and their equations to their sequences.